So in this video, I'll be going through the composite area notes. A PDF version of this, all filled out, can be found on Google Classroom under Interactive Notebook Pages. Those of you who got a paper copy of this in person, you have this first sheet. I extended the notes a little more to include not just composite shapes, but also examples where you have to find areas of either irregular or complex kind of spaces or shaded regions. Okay, so to start off, the algorithm for finding the area of a polygon is up there in the top. It states that you just separate the figure into simple, familiar, non-overlapping shapes and then find the area of each of these shapes. Then you add all the areas together. Essentially, composite figures or irregular figures are just shapes that we don't have a direct formula for, but rather ones that you can split into smaller, more familiar shapes. Okay, so up here, I give you the formulas for all of these different kinds of shapes that you should be familiar with. Just to help you out in understanding them, remember when we look at a square, all the sides are equal to one another. And in this formula where the area is the side squared, the side is just that right there. So if you have one of the lengths of the sides, you just square it to get the area. When we think about the area of a rectangle, the length is always going to be the longest side, and the width is always going to be the shortest. Area of a parallelogram. This is the height. Sometimes you might also see the height outlined on the outside, but that's the height. And then the base is always going to be the measure of just that bottom segment of the parallelogram. Base has a similar concept within triangles. And then the height is either the vertical measurement that goes from the top highest point of the triangle to the bottom. Sometimes you might also see triangles labeled with heights like this, where it's on the outside. Okay, but the area of a triangle is just half of a rectangle. And then last but not least, when we look at trapezoids, the formula is 1/2 height times the sum of the bases. So height, once again, is just that vertical length. And then for the bases, it doesn't matter which one you label, base 1 or base 2, but it's just going to be the two horizontal lengths since the trapezoid has two parallel sides. Okay, so let's go through 3 examples. This first one is just to help warm you up on how to find the area of a composite shape. And then you'll see on the bottom too that I kind of break down what are the smaller shapes in that figure. You could either put your work on the inside here if you're going along with doing these problems on your own, or I have a lot of students who like to put the final areas up there in that diagram and then just adding whatever you get in those two. So for the smaller square, we have 6 inches by 5 inches. So that gives us an area of 30 inches squared. Then on the bottom rectangle, you have 9 inches and 13 inches. And I'll show how I got that. So that's 6 times 5. 9 times 13, and then that ends up being 117 inches squared. And so if this is 30 and if this is 117, then our full area for this shape is 147 inches squared. Okay, and if you notice too, whenever we express area, you always want to square the units. And the reason why we're doing that is because you're not just multiplying the numbers, you're also multiplying the dimensions. So this is 9 inches times 13 inches, and inches times itself is just inches squared. Okay. Over here, the dimensions of this triangle were 4 yards and then 7 yards. So the area, if you look at the top as a reminder, area of this triangle is going to be 1/2 times the base times the height. And then half of 28 over here is going to be 14. So that's 14 yards squared. For the rectangle, it's 7, or the square, it's 7 yards by 7 yards. So that's just 7 squared, which gives you 49 yards squared. For a parallelogram, we have 3 yards and 7 yards. And so that area would just be 3 times 7, which is 21 yards squared. If we add all these areas together, so I have 21 plus 49 plus 14, double check my math, I get 94. Let me verify that with my calculator real quick. 14 plus 49 plus 21. Yeah. So we have 84 yards squared is our final area here. Okay, and last but not least, we got a triangle that has a height of 9. And then, even though it isn't marked, the base of that triangle is 15. And then I'm going to go ahead and just label the dimensions here so I don't have to worry about it later. You obviously don't have to do this. I just do this to help those of you see where I got the answers to my answer key from. So the height here is 4 centimeters. One of the bases here is 18 centimeters and the other is 15 centimeters. To get the area, remember for triangles, it's half base times height, so it's half 15 times 9. And I'm going to plug that in real quick. 15 times 9 is 135. Half of that is 67.5. So that's 67.5 centimeters squared. The area here is going to be 4 times 15. That's 60 centimeters squared. And last but not least, the area here, remember the area formula is half the height times the sum of the bases. So you're going to do 1/2. The height is 4, and the bases are 15 and 18. So order of operations, I'll do 15 and 18. That's 33 times 4 is 132. So this is 33. $132, and half of 132 is 66. So if we follow the algorithm, add all of these together, I have 67.5 plus 60 plus 66. That gives me 193.5 centimeters squared. Okay, so these are how you get composite areas So if you went through this whole process I just did, all I did was find the area of each shape individually and then added them together. Now, with the examples like the one that you see in the bottom, you're pretty much going to do the same thing, but instead of adding, you're going to end up subtracting the area that isn't shaded. Okay, so when it comes to these kinds of problems, the key thing is to subtract. So you want to subtract and then more specifically, we want to subtract non-shaded areas. Okay. And it's far more straightforward than you would think. So the large rectangle over here, the way I get their area is just 8 times 10. So that's 80. And the area in here is just 5 times 8, which is going to be 40. And these are both feet squared. So to get the area of this final shape, I just do 80 minus 40, because 40 feet squared is the area I'm taking away. And our final is 40 feet squared. Okay. Don't freak out when you see circles in your diagram. If you want, you can include at the top the area for a circle. Remember, in our circles, the segment that goes from the center to the edge, that's the radius. And so your area is pi times your radius squared. Okay, so what I'm going to do is first get the area of this square, and it's just 10 squared since it's a square, so we just square that dimension. You get 100 centimeters squared. And then for the circle, even though it's not labeled, if you think about the center of the circle to the edge, if the full length across is 10, then I just get half of that. This is 5 centimeters. Okay, so that means the area of the circle this is my radius, right? It's from the center to the edge. The area of the circle is just pi times my radius squared. And if I keep it in terms of pi, that's just 25 pi centimeters squared. To get the total area, I would just get, of the shaded region, I would just do 100 minus 25 pi. And if I plug in 3.14 for pi, that would end up being about 100 minus, let me see what 25 times 3.14 is real quick. Minus roughly 78.5. And then that would make the area of our shaded region 21.5 centimeters squared. Remember, this is just an estimate since we use 3.14. If you want to keep it in terms of pi, you can just keep that expression. Okay, and last but not least, the problem on the bottom, it may look pretty complicated, but it's actually very similar to the first example I showed you guys. So I would get the area of this full square, and there's different ways you could do this problem. I'm going to show you the way with subtraction. You could also do it using addition as well. But essentially, the area of this full square, so this full length, I just add all of these together. Same thing here. It would be 14 meters by 14 meters. So the area of the square would be 14 times 14. And then that would just be 196. And then if you notice, there's 4 of these little squares that are cut out, not included in the shaded region. And they're each 5 by 5 or 25s, right? So each of these small squares are 25 meters each, or 25 meters squared each. And since there's 4 of them, I can multiply that by 100, or not by 100. I can multiply 25 by 4, and then I get 100. So 100 meters squared is the amount of the unshaded. So I would just do 196 minus 100 to get my final answer of 96 meters squared. Okay, so that's if I use subtraction. I could also use addition, where you just get the area of each of these, right? So this is a 4 by 5, this is a 4 by 5, and these, I have 5 4 by 5s. So I could have just gotten it that way as well. Okay, but that's how you get areas of shaded regions. Shoot me an email and let me know if you have questions, and I hope you guys stay healthy and stay safe.